So we're going to be, I guess, looking at the Buffalo Terastation, whatever this model number is. Talk's name is Unhinging Security on the Buffalo Terastation NAS. We'll find out why I chose that title in a second. But just the obligatory Who Am I section. My name is Sindermann. I work for independent security evaluators. I do security or application level security audits. I kind of grew up as a traveling performer, sort of, thing. I live in a bus. I like to hack, I like to IoT garbage, hack obscura, all that good stuff. I like to share what I find. So again, ISE, we do black box, white box, security development, all that good stuff. More importantly, we recently came out with ISE Labs, which is the research division. And we started the SOHO 2.0 project, where we kind of revived our SOHO 1.0 project, where we essentially took a load of IoT garbage and found out just how terrible it all is. So this time, we found over 100 CVs so far, and this device was one of the ones we poked at. So the device itself is the Terastation, whatever model number that is. We'll find out in a sec that the model number doesn't really matter. It's kind of a SOHO/enterprise thing. They call it business grade. It's rather expensive. Also wouldn't call it business grade, but again, we'll find out. It's made in Japan, has an admin interface via web application, which is kind of my bread and butter, so that got my attention pretty quick. But why do we care? Like, there's IoT garbage all over the place. The thing about this device is that it demonstrates a few key concepts quite well. More importantly, key concepts that apply to anyone looking to get into performing application security assessments, or just looking to break IoT devices for fun or profit, your choice. Stuff like approaching an unknown device, how small mistakes can have very large impacts, and abstraction can obscure those mistakes. But as we shall know, obscurity for obscurity is no security. There was also recently the Maryland Democratic Party. Apparently they had all of their data on a Terastation on the internet. And then pretty much every other country found it. So that was in the news. Also root shells, because root shells, and the vendor response is a bit of a gem, but we'll get there. So what got me really intrigued with this device was our first interaction, where we encountered a lock. The NAS can be locked, and it was. The key should have been with it. We didn't do that, so we had to do something about that. So the lock's job is to deny unauthorized access, and it was doing it quite well. The hinge, its job is to allow the door to open easily and reliably. So what if we give the hinge a little helping hand? Turns out we can just pop the hinge open and completely bypass the lock. And this kind of set the theme for this device. So I guess we'll get to that in a minute. But, oh wow, looks like I broke something. But you get the idea. So where do I start? That's something that I hear surprisingly often when I am talking to people about the research that I've done, research that I intend to do, and a lot of their goals regarding IoT or application security in general. And the things that I've noted so far, both from input from others, the wide resources on the internet, and my own personal experience in SOHO 2.0, and my job in general at advocacy. There are kind of 3 stages that are all pretty intertwined. Some people break them up in more or less, but for me, I like to see them as 3 stages. The first one being gathering information. Start out with finding manuals, known vulnerabilities, GPL source code, which can be quite valuable. And downloading firmware, especially for these devices. Sometimes they will not give you SSH, sometimes they will. But having that firmware oftentimes allows you to extract a very similar copy of the file system and perform static analysis there. Also, for web applications, building a site map, kind of go through, flip every switch, push every button, record everything you do, so you can go back and troll through that data and find anything fun inside of it. And previous work is also quite important, and we'll cover that in a little bit. From there, I usually go into analysis, active testing, scanning, static analysis, but I always come back and continue gathering information as I'm performing that analysis. The same thing with expansion. You'll go through, you'll find SSH or telnet or give yourself a shell. that's not where you stop. That's where you go back, you gather more information, build out more, a larger understanding of what you're working with, and then expand your access, find more bones, use those bones, and keep going. And again, you just go through and repeat. And one big thing that I like to say to new people is go for the juicy bits first. By juicy bits, I mean stuff like awkward stuff, database operations, interactions with shells, anything that can get you a very juicy payout if you find an issue. And stuff like hidden or debug endpoints. A surprising number of IoT devices have those, and sometimes they just forget that authorization is a thing on those endpoints. And from there, again, go further. Keep looking, keep pushing, and don't be blinded by those juicy bits. Because there can be some very fun functionality and vulnerabilities and stuff that doesn't immediately appear to be something conventionally juicy. Stuff like anything that's overly complex, because chances are the developers don't know what's going on. Maybe we won't either. We can build an understanding, find any issues with it, perhaps we can use some fun. But on that same note, if it's oddly simple, there's a good chance they have some oversights there and you can abuse them. Some deviation from best practices, all that good stuff. Some of it does come down to kind of following your gut. Stuff like you can see that someone they've implemented, say an API or something, but it just doesn't feel right. And there's usually a reason behind that feeling. And follow that feeling. With that said, that gut feeling usually requires some experience and some knowledge, but experience and knowledge can be gained and done. So I guess let's do that. So approaching the Terastation itself, this is kind of what I did to dig through and find all these issues, along with my colleagues in the research team. The initial section, gathering information, again, flip every switch, push every button, record everything you do so you can control through it. And while doing so, I determined that there was no SSH functionality. Now, for a lot of these devices, especially NASs, you will have SSH, so you can just log in and get some sort of shell. Sometimes root, sometimes not, but that can give you a very good foothold for the rest of the assessment. In this case, we didn't have that, so we need to find a replacement. I also found that there was loads of previous work on NAS Central core. I think NASCentral.org kind of died for a few months, but it appears to be back up. If it is up, it's a great resource, and I highly recommend going through it. It's a website kind of focused on hacking NASs. Surprise, surprise, that's rather what we're doing here. And then from there, I delved into analysis. The firmware is available online, but it's encrypted. NASCentral.org has all the encryption keys, so you can just pull it out, get a file system, and start doing static analysis. And the sitemap, again, that has all of our information in it, and through that information, I found some verbose API errors that included the location of the file that encountered the issue. So instead of having to trawl through all that file system from the firmware, I can just take that error, see, oh, it's in this location, delve right into the source code. And it showed that it was actually running Python. However, the Python was precompiled. So if you ever worked with Python before, you may know that when you run a Python script, you'll end up with a PyC file. We only had the PyC files, which are precompiled. However, with Python, it's extremely easy to decompile that or uncompile using something like Unhinging 6. So we just ran that, uncompiled all the source code. Pretty much all of it came out okay. A few files were iffy, but for the most part, we had a very real source code to work with. And from there, just went into exploring source. And from there, it was expanding, get a shell, try and find those vulnerabilities that can give us more access and a foothold and expand our scope so we can find more information and continue finding vulnerabilities. Again, just go through and repeat. So one of the first ones that I encountered was CB 2018-13324, which means nothing. It's an LFI pass. So what kind of prompted this was that the JSON RPC API handles all staging requests for the entire device. It's one endpoint. And that API uses a SID parameter or a security ID. And that inhibits a lot of things, such as performing actions that require admin privileges. I'd like to do that. It won't let me. There's CSER. I'd like to do that. It won't let me. Yeah, turbine. Again, no. I do not like this SID, so I want it to go away. So I'm going to try and find a way to do that. That's where Buffalo JSON RPC2 came in. So in this file, almost immediately, like this is the first two definitions in the file, there's something rather interesting. You can see, skip off. Okay. Yeah, sure. Okay, sure. So it seems that skip off is defined somewhere, but not here. So if we just search through the file, in bin / skip off, we got another fun segment where we see that it seems that they're using the HTTP host environment variable, and if that's localhost, then it's allowed to skip off. Now, if you're familiar with HTTP headers, you might know that this could be interesting. If you're not, I'll show you why. So, if we think about this from a developer's point of view, the device needs to interact with its own API in some form or another, and often need a bit of a pain in the butt. It usually isn't, but I don't know. Pretty much everyone just does this. So they just build a whitelist for localhost. So I guess their reasoning is that the host header is always localhost in a local request, and it's never localhost in a client request. So the host header being localhost means that it's a local request. Straightforward. This isn't quite true though. Yeah, job done. Good to go. The host header is client controlled. So the host header is always localhost in a normal local request. The host header is never localhost in a normal client request. So the host header is just, the host header being localhost just means it's a host header with localhost. It doesn't have any other significant meaning in this regard. And what I think causes this misconception is the idea that the host header is used for some sort of routing. And in load balancers, this is actually correct. The host header is used to determine where that host needs to go to. But in any other situation, that's not quite true. So the host header is at the application layer, and all your routing decisions are made all the way down the networking layer. So that host header is making no determinations as to where that request is actually going until it hits the server. It's up to the server to do something with it. So we have issues like this, where you can just change some stuff, off bypass. So we have a normal request here. We're trying to reboot the system. We have a junk SID, and it says that our session is invalid. Truly hope that that's legible. So from here, I figured, let's just replace host with localhost, like that. We still get an error, which is disheartening, but it's a good error in some ways. You see that the error is rather different from what we had before. It says that the parameters are invalid and that reboot was given one too many parameters. The only parameters we gave it was the security ID. So if you just remove the security ID, it says that the result was null, and the NAS just kind of makes some beep noises and turns off, which is probably not a good sign for anyone using the device, but for us, that's pretty great. So, TLDR, the JSON RPC API skips all objects if the HTTP host header is localhost. So the HTTP host header is client controlled. Not good. As far as exploitation goes, you just set the host header to localhost, so you get any SID parameters, fire it off, and boom, you're an admin. But remember how I said there was no SSH, no shells to get? What's the fun in having admin powers if you can't get a shot? So on to the next part. That was CPE 2018-13321. It just exposed internal methods in a rather fun way. So the API modules were strange. As I was digging through them, looking for those juicy bits, like anything interacting with the command line, spoiler alert, there were a lot of those. There was command injection everywhere. Command injection is everywhere in IP devices, so we're just not going to deal with that. We're going to do something more unique, I guess. So in this API, there was no distinction between internal and external methods, or at least not in a way that you normally see in Python application. There were no configs for these endpoints. There were no decorators, like pi notation, none of that sort. That didn't sit right. I didn't know why, but I knew it was something that I wanted to investigate. So I did. And that led me to user local bin, or user local lib, it's just NAS API. It's the main Python file for the server. And it has this massive, terrible loop that essentially loads in any function that module that is callable and is not prefixed with an underscore. Now, it's very common to have all of your kind of local functions with a underscore prefix, and all of your public functions without that prefix to denote to. They just took that a bit further and decided, if it's a public function, it should be the API endpoint. Makes loading API endpoint super easy, but potentially a little too easy. See, the thing about Python is that, what happens if we import OS in one of those functions? Well, as far as OS goes, it doesn't start with an underscore, but it is callable, so that won't be an endpoint. What if we import from OS star? Well, anything that's callable in OS that is not prefixed with an underscore becomes an API endpoint. A lot of very dangerous API endpoints. But sadly, there was no OS import star. However, there were some fun ones. In particular, there were a few files that import everything from confutil. In this case, it is wbfs.py. I honestly don't remember what it was, but it's some module that's included on the device or some sort of backup functionality or call correctly. Confutil, anything in there becomes an endpoint. So let's dig into that, see what we have to work with. So confutil exposes read conf and write conf. These are kind of designed for interacting with shell-style configs. Essentially just key equals value. I don't know whether it's shell-style, but that's what they said in the source code. So both of these endpoints in WBFS become, or both of these become endpoints in WBFS because of the import. So just so happens that write conf can pretty much write arbitrary shell scripts anywhere on the device. Sadly, they're not executable. So we can't just drop one of these shell scripts in int and then get a shell whenever the thing boots up. We can overwrite configs, but most of those aren't going to be used as shell. Except for perhaps cron. If you're not familiar with cron, it's this wonderful little utility that allows you to schedule commands. Something that can run, every day, every hour, on certain hours of certain weeks, that sort of fun stuff. That can also run on the minute every minute. Should be quite nice for a shell. So then we have something like this, where we just use our old off bypass exploit. We just tell wbfs.writeConf to just modify root's cron tab, take the original cron tab and just stick in this new one that executes telnet D with a listener on port 8383 with a shell of bin bash. So it has an authentication. Just start that every minute. And it just says 200 OK. Sadly, with cron, it's not going to automatically reload that file. Usually, I think you have to sync up it. I could be wrong, but I do know that it will not just reload that file. Unless we should reboot the thing. We can do that. Because with the bypass, we can do whatever we like. So just reboot the system, make some fun beeps, turns on, and then it starts spawning a shell every minute. Which just so happens to log in, and of course it's an IoT device, so what else would they run their app as? So root. So we get a root shell every minute on the minute. Just because their API loading function was a little too overzealous. We managed to use an API endpoint that nobody wrote. Oh well. But what really struck home this device. Oh, sorry. The TLDR. The endpoints in modules need to be defined. Any function with functions prefixed with an underscore are normally internal. Just load any callable that's not prefixed. So the function is defined in the module may not be the only ones. From X import star, WBFS imports everything from confutil, write conf, We can write arbitrary files anywhere. We just write whatever we like, get a shell, and good to go. But what struck home kind of the terribleness of this device, and just IoT in general, was the disclosure timeline. Now, these are usually quite dry. This one, for the most part, is. We tried to contact them regularly, send emails to multiple locations. Eventually, we just sent them the bombs to multiple locations. Heard nothing. Sent the CVs to multiple locations. Still heard nothing. So we announced a public live stream demoing the vulnerabilities as we released them. I did my demo live stream, and we released our vulnerabilities. And then the next day, Buffalo America's retweeted the link to my live stream. This was the first time they've ever interacted with us. They didn't respond. They didn't even fix the vulnerabilities that they retweeted. So I guess they effectively retweeted the link to 7.0 days in their product, which is not something I expected to happen. That had me pretty confused for weeks, I guess. Eventually, they realized that was a terrible thing to do and deleted. I have no idea when that happened, but so they deleted the tweet. They realized something was terribly wrong. So, of course, all of the vulnerabilities have been fixed. The party's over. No more fun to be had by us hackers. No. I'm not really sure why they haven't fixed anything, but they haven't. Like they have to have known that something was wrong. They deleted the tweet. It's been almost a year since we initially tried to contact them. And while I was checking for patch availability, I want to say last week, I decided to download some other firmwares that they had. So remember how I said the model number doesn't really matter? Yeah, if it's a Terastation, you can probably get rootness still, including the like 17 grand ones that are their flagship models in enterprises. But that's IoT. Except it's not really IoT, but oh well, that's what they said it was. So yeah, so that was quite the trip. And I guess that's about all I have today. That probably went way past the intros, but such as it is. But I think that gives us a lot of time for any questions. So if you have any, now's the time. I have all of my resources with me, so if you want to poke at anything in the verse state or anything about the device, now's the time. You're also, I'm not going to make you stay here. You can go.